Hi everyone, in this video I'll be explaining Chapter 2 of Data Science, which is all about data. We'll look at what data is, the different type of data and attributes, problems we face with messy data, and how we prepare and compare data. This chapter is most important because data is the foundation of everything in data science. If the data is not understood properly, then all the analysis later will be wrong. Moving on to the second slide, what is data? Data is basically a collection of objects and their attributes. An object is something that we're studying, like a person, a book, or a product, while attributes are the properties of that object. For a person, attribute could be something like age, eye color, or height. For a book, it could be the title, author, or number of pages. Moving on to attribute values. An attribute is the category, but the attribute value is the actual detail. For example, 165 is the value. Or if the attribute is eye color, then the values are brown, blue, or green. Same attribute can be measured differently, for example, centimeter versus feet. One important thing to note is that the same attribute can be measured in different ways. Height can be in feet or meters, but it's still the same attribute. On the other hand, two different attributes can share the same type of values. For example, ID numbers and age are both integers, but they don't mean the same thing. ID has no natural maximum, while age does. Moving to the next slide, types of attributes. There are four main types of attributes, which are nominal, ordinal, interval, and ratio. Nominal are labels or names, for example, eye color, blue, green, brown, or ID numbers. They just tell things apart, but there's no order or size. While ordinal have an order, for example, grade A, B, C, or level like small, medium, large. You can tell which is higher, but you can't say exactly how much higher. Interval are numbers where differences matter, but zero doesn't mean nothing. For example, for Celsius temperature, if today is 20 degrees and tomorrow is 30 degrees, the difference is 10 degrees. But 0 degrees doesn't mean no temperature. And the last one is ratio, which is the most powerful. Here, both differences and ratios make sense. Here, both differences and ratios make sense. The 0 really means nothing. For example, height, weight, or age. If one person is 20 years old and another is 40, we can say that the second is twice as old. That works because age has a true 0. Moving on to discrete and continuous. Another way to look at attributes is whether they are discrete or continuous. Discrete attributes have limited numbers of value. For example, numbers of children, you can have 0, 1, 2, or 3 kids, but not 2.5 kids. Another example is zip code. It's a fixed code, not a continuous number. While continuous attributes can take real value, for example, height, weight, temperature, you can measure someone's height as 165 centimeter or 165.3 centimeter. This difference matters because some data mining techniques works better with discrete data while others are designed for continuous value. Moving on to types of data sets. Data can come in many different forms, not just in simple tables. Let's start with record data. Record data is the classic table format like student grades in a spreadsheet, when each row is a student and each column is an attribute. For example, you can see the left image. You have John Doe as the first student, which class, and the grades of the student. Going to document data. Document data is text. For example, if we analyze articles, we can count how many times words like game or team appears. This is called bag of words model. Going to transaction data. Transaction data is common in shopping when each row is a shopping trip and the items are what was bought. For example, you can see the image as the first one. You see bread, Coke, and milk are bought together in one trip. Going into graph data are like connections like social network or website. And the last one is ordered or sequential data, which includes time series, stock prices, or DNA sequences. So depending on the field, we can face very different data structures. Moving to data quality problems, real-world data is almost never clean. Some common problems are noise, outliers, missing values, and duplicates. Going into noise, these are random errors in the data. For example, the TV signal being poor, making the image quality degrade, while outliers are data points that are usually, for outliers, these are data points that are unusual compared to the rest of the graph itself, as you can see in the second image. And the third one is missing values. For missing values, these are data that are not recorded. For example, you have recording for November 14, November 15, but no recording for November 16 due to like a power outage or something. These are missing values. Duplicates are the same object recorded twice. For example, the same customer is stored twice in the database under two email addresses. Moving on to data preprocessing. To fix messy data, we do preprocessing. Some methods include aggregation, which is combining data. For example, instead of looking at every city separately, we combine them into different regions or countries, as you can see in the top image. Sampling is when we use only some parts of the data when the whole dataset is too big. If the sample is a representative, it gives almost the same result as the full data itself. Dimensionality reduction is removing unnecessary attributes. For example, if you're predicting GPA, a student's ID number doesn't really help, so we can just remove it. Feature creation is building new attributes from old ones. For example, instead of having height and weight separately, we can create BMI, which is more useful. And the last one is transformation, which is changing scales, like converting all heights into meters or normalizing data so that the attributes can be compared fairly. After doing these steps, you will see that the data is cleaner, smaller, and more useful. Now, moving to similarity and distance. When analyzing data, we often need to ask, are two objects similar or not? Similarity measures how alike they are, and distance measures how different they are. For example, Euclidean distance. The straight line distance between 2 points, like on a graph, as you can see in the first image. Cosine similarity is used for documents. If two articles share many words, their angle is small and the cosine value is high. Jacquard similarity is used for sets like shopping basket. Like if two customers often buy the same items, their Jacquard similarity would be high. These measures are the backbone of clustering, classification, and data mining tasks. Now, in conclusion, data is made of objects and attributes. Attributes can be nominal, ordinal, interval, or ratio. Data can be discrete or continuous. We deal with many different types of data sets, from tables to documents, transactions, and graphs. And real-world data is messy with noise, outlier, missing values, or duplicates. And pre-processing techniques like aggregation, sampling, dimensionality reduction, and feature creation makes data ready for analysis. Finally, similarity and distance help us compare and group data objects. Understanding data is the first step. Without it, all later analysis in data science won't work properly.